Hi, welcome to the second video for the introduction of LabView. In the previous video, we have seen how to transfer text message from one point to another, and also we have seen that the number could be converted to hexadecimal value, which was just to show you that you can convert one form of data to another. That is the usage of conversion techniques in LabView. Now, I'll demonstrate a code with a simple mathematical operations like addition, multiplication, division, etc. and on a numeric data. And also I'll just demonstrate to display the output on the graphs and charts. So let us try to know what is the difference between graphs and charts also. So let us also see the usage of structures. So that is the loops. I'll just consider the conversion of degree Celsius, conversion of temperature from degree Celsius to Fahrenheit as a simple code, so which could demonstrate the purpose of loops in the LabView and the purpose of structures in the LabView, or the graphs and the charts in the LabView. So just a simple code, the expression which relates degree Celsius and Fahrenheit is as shown over here. So that is, if I have temperature which is expressed in degree Celsius, to that add 32 and multiply the resultant by 9 by 5, which is almost comes to around 1.8. Degree Celsius added with 32 multiplied by 1.8 gives the value which could be expressed in Fahrenheit. I'll just go to so same expression will be put in a form of blocks in the LabView. Whatever the temperature we have in degree Celsius, we shall see what is its value in a Fahrenheit. So go to switch over to LabView portion. So as previously said, as soon as you open LabView, you will have a block diagram and you will have front panel. So now I'll write the block diagram for the conversion of temperature which is expressed in degree Celsius to Fahrenheit. Let me consider the temperature in Celsius as one of the value, that is 32. To go give the value 32, right click on the block diagram where you will find the functions. In that, go to numeric, where I'll be selecting one of the numeric constant. Take that, let the data over here be 32. So this is the value which is expressed in Celsius. To convert this into Fahrenheit, I need to add 32 to it. So right click once again, go to numeric, select one more constant where even that value is 32. I need to add both the values. Right click, go to mathematics, select numeric. In that, select the adder block. Connect both the values to the adder block. Wire both the values to the adder block. Next, this has to be multiplied by 9 divided by 5. So I'll just take up one more constant. To take up 9 and 5, you can just copy, Ctrl C, select one of the value, copy and paste it. So this block, let me take it over here, so whose value will be 9. So once again, you can copy the block, whose value could be 5. To divide this, to go for the division operation, once again right click, mathematics, numeric, go to divide. Wire 9 and 5 to the inputs of the divider. So this added and the divided, that is 9 by 5 divided data have to be multiplied. So once again right click, go to mathematics, select the multiply block. Wire the added data to one of the input to the multiplier and the divided data to the other input of the multiplier block. So this has to be, this value, the resultant multiplied or the product have to be seen. To observe the result, right click near the multiplier block, create an indicator, where as soon as you right click and create an indicator, you could see on the front panel you have the block which is indicating x multiplied by y. X multiplied by y. You can increase the font size of this size. Go to size, select 18. Yes, the font size of x multiplied by y has been increased. So now I just run the code. Meanwhile, the highlight button is in an on position. Run the code. You could see the movement of the values on the wires. Yes, the resultant value is 115.2, which is in Fahrenheit. So now suppose we have a situation in the plants where the temperature of a furnace have to be continuously monitored. So that is, the temperature might be varied continuously. So over here I have taken the temperature which is a fixed value as 32. So instead of 32, the temperature might be continuously varied. So where that variation of the temperature will be indicated by selecting a block, go to front panel, select numeric, in that select vertical fill slide, where you could vary the temperature over here. Yes. So as soon as you select the slider, you could see the same block on the block diagram. So now I'll just delete this constant value and connect the slide as one of the input to the adder. So where now the slide contains the variation with the temperature of a plant. Run the code. Yes. As I vary the temperature, you could see the corresponding variations at the indicator, which is the product x into y. So now suppose we'll have a situation where the temperature need to be continuously monitored. To monitor the temperature continuously, so instead of just picking up the one value, we'll have to monitor the temperature continuously. So where I'll just, to do that, I'll just delete this indicator and take up a same vertical graduated bar, which indicates the variation at the output, variation of the temperature at the output terminal. Yes. just expanding it. So now this will be connected over here. Yes, run the code. Yes, so I don't know the value. To indicate the values over here, right click on the slide block, go to scale, and the style format, you can choose any of the style format you wish. So roughly now it is around 60. If suppose the temperature need to be varied continuously, so temperature need to be monitored continuously, where the conversion of Fahrenheit to degree Celsius have to be done continuously. So in such case, the entire code will be selected. Select the entire code, and this entire code have to run continuously. To run the code continuously, right click on the block diagram, go to structures, select while loop. Inside this while loop, you have to place your code or the programming part. So you can see a control button, a loop condition, which is just to indicate the stop. So go over there, right click, create control. So you will have a stop button on the loop. So now I'll just run the loop continuously. Run. At the same time, vary the input temperature. So you could see the variation at the output, which is indicated by slide 2. Just stop it. The graphical display part of the same code will be continued in the next lecture.